Before we leave the topic of complexity, I want to do one last thing. I want to give you a visual way of getting a sense of how different these different complexity classes are. Because you might say, does it really matter if our code is quadratic versus linear, or log linear versus linear, or linear versus log? And of course, it depends on the size of the problem, of the particular instance of the problem. But for large-scale problems, the complexity of the worst case can make a really big difference. And I want to give you a sense of that. So just to do that, let's take a look. What's the difference between a constant algorithm and a logarithmic one? So what I've graphed here is the amount of time it takes for an algorithm that's constant that has 20 steps versus a logarithmic algorithm that has only one step within its loop. And notice it takes an argument of size almost 1,000,000 before the logarithmic algorithm actually catches up to the constant one. Of course, if the log algorithm had 20 steps, it would scale up beyond this. But this is really a way of saying log algorithms grow incredibly slowly in complexity, and therefore they are really powerful. And in many cases, they're almost as good as a constant time algorithm. Log grows slowly. Log algorithms are great things if you can find them. They're not easy to find, but when they are really great. Okay, now let's move up that chain. What about the difference between a logarithmic algorithm and a linear one? Well, this difference is big. That blue line at the bottom is a logarithmic algorithm, or a logarithmic function if you like, and the green line, of course, is the linear one. And you can see that the linear one starts to very rapidly outstrip the logarithmic one. And again, the obvious observation here is that logarithmic clearly is better for large-scale problems than linear ones. Doesn't imply linear is bad, it just says that log grows so much more slowly. If we can find a log algorithm, we would really like one. Let's move up the chain. Linear versus log linear. And of course we know that they're going to get worse, but here you can see that it doesn't grow as badly as you might have expected. There's the linear algorithm in blue down here, this one. There's the log linear one, and it's growing, but the growth isn't horrible. Okay? And as a consequence, what this says is that while log n may grow slowly, when it's multiplied by a linear factor, the log growth is much more than just the pure linear, but they're still quite valuable because the growth isn't getting badly out of hand. All right, so we're seeing each one of these things has a little bit more of a growth. Let's look at another one here. Log linear versus quadratic. Here you can see that the growth is actually going up much more rapidly. Right? Quadratic is really starting to skyrocket. And again, the log linear one looks like it's almost flat compared to it. And again, the observation here is that quadratic is often a problem. Okay? Some problems are inherently quadratic, but if it's possible, we always want to look for a more efficient solution. And we're going to see that we're going to regularly see quadratic problems, so this is an issue. If we can find a log linear one, we'd like that solution. And then the final comparison, well, kind of is mind-blowing. Exponential algorithms are incredibly expensive. And in fact, here's a plot over here of an exponential versus a quadratic one, and you can't even see the graph because the exponential one is tucked right along this graph here, blowing up really fast. So if I replot this on a log scale, which makes the exponential one now linear, you can see how much better the quadratic one is. And this is why that's a big difference. As I said earlier, there's a big difference between n squared and 2 to the n. 2 to the n grows really fast compared to n squared. And this is just a visual way of reminding you of that. If you can, you want to avoid an exponential class algorithm. Even a quadratic one is going to be better by a long shot for any reasonable size problem. So these little graphs just give you a way of visualizing the differences between the different classes of algorithms. And throughout the rest of the subject, we're going to come back to talk about different classes of algorithms and what their costs are.